Okay, so in this video I'm going to talk about the entire meshing process, start to finish, for this 81 millimeter mortar geometry. I'm actually going to go through, I've just imported the geometry, I'm going to go through the cleanup process, surface meshing, then volume meshing, and then some kind of more advanced topics, how you can improve your mesh, improve the resolution in certain areas, and then export it to the solver. So we're going start to finish. It's going to be a long video, but it's going to have a lot of useful information in it, a bunch of tips and tricks that I've learned over the years working for Pointwise, working with the software. Okay, so with that, why don't we get started? Like I said, I've imported the geometry, and it's an 81 millimeter mortar. We are working in millimeters, so all units will be in millimeters. The first thing that I want to do is I want to create a watertight solid that represents this geometry. Okay, it's a single mortar. It should be watertight. Okay, and the benefit of it being watertight is that I can put a watertight surface mesh on this thing in as little as one click and get going right away. Okay, so with that, I need to see how clean the geometry is. That's really my first step. Okay, so there are a few things that I'm going to skip, some terminology and stuff like that. For the most part, I mean, you can look through the tutorials, other videos, and that sort of thing to get that information. I kind of want to get through this, and you can always stop, pause, or rewind and go back and watch different portions of it if you'd like. But one of the big things that I want to talk about before I get started is the mask panel. The mask panel is going to become key because there's going to be a lot of manipulation and selection going on. And the mask panel is like a filter. It allows you to do very targeted selection. So for example, if I click this, that means I can only select blocks. Block is a volume mesh. If I select this, I can only select a domain. A domain is a surface mesh. This is a connector or a grid curve. A database entity, which is our terminology for geometry. A database boundary, and then a spacing constraint, and then a group. I'm not going to be using groups, but I'll be using pretty much everything else. To pan around the scene, shift right click will allow you to kind of pan around the scene. Control right click will allow you to rotate about that red rotation center, and you can move that using control shift right click. You can move that rotation center anywhere you would like. If you want to query the location of a point, alt center click will allow you, or alt right click, sorry, will allow you to do that. That keyboard shortcut, alt right click, will actually, or that hotkey will allow you to do this on a Windows, Mac, or a Linux machine. So just some of the things that I'll be using pretty heavily throughout this. Okay, so now that we've gone through that, the first step, how watertight is it? Well, I'm going to select my geometry. Note that I've selected my database mask, and I'm going to go create, assemble, models, and I'm going to click assemble. And you'll notice that I have, it says in the table that I have 4 models. You can see that by the 4 different colors, okay? And I have 46 Laminate boundaries. So that's a really important piece of information when you are determining if this is watertight. A Laminate boundary is a free edge. It's a gap, okay? Especially in this model. We know it's a single watertight body. We need it to be watertight. And so a Laminate boundary is going to represent a gap in that body. So where are those gaps? Well, they're highlighted in red, and you can easily see them. In this case, we've got a pretty significant gap up here near the nose. There's a little bit smaller gap right there. As we move towards the back, looks like we have some holes. There's a gap right there, and there's a hole in the back. All right. So there's several things that I'm going to demonstrate here. I'm going to walk through a lot of our solid modeling tools to clean up this geometry. All right. So something else you can do is just grab the geometry again. Control A is select all. And you can go examine boundary proximity, and this is going to allow you to look at the distance between adjacent database surfaces. And what I like to do is under the color bar tab, it automatically picks the min and the max, but I'm going to set this to like 0.1, and there you can actually see those gaps that we saw before. If we zoom in here, we can see, if you look right up here and right down here, and I hover over that, you can see that that distance is 0.4. So that gap is 0.4 millimeters. Okay. This gap is 0.1 millimeters. So it's pretty small. We can actually probably just fix that using the model assembly tolerance. This gap is probably large enough that we should use a surface to kind of bridge that, and that's what I'm going to do. I'm going to create a surface to kind of fix that gap. Okay, so with that in mind, I'm going to grab everything and go to my model assembly, create assemble models. I'm going to be using this menu rather than the toolbar action to assemble models, just because you can see the colors, you can see how it's operating and that sort of thing. I think it's more beneficial to see that. I'm going to use the edge tolerance 0.15 because that's just a bit larger than the gap in that region that I'm trying to fix. And you'll notice that by doing that, it automatically heals that gap. Okay, we still have this one, but if you remember, that distance is 0.4. So if I increase to say like 0.45 and click assemble, it'll heal over that gap as well. Okay, but like I said, I'm not going to do that for that gap. I'm actually going to create those surfaces because sometimes you may have gaps that are a little bit larger than you want to use for the edge tolerance. Okay, I typically set an edge tolerance that's small enough to heal my really small gaps rather than going and bridging much larger regions that I could just create a surface to kind of fill. So I'm going to bring this back to 0.15 millimeters, and I'm going to come in here and create a surface. Now it's really easy actually to create a surface to bridge this gap because I can access the boundaries of my surfaces, my database entities. So I'm going to click that mask, I'm going to pick that edge or that boundary, and I'm going to create a swept surface. Okay, now I'm going to pick, my rail selection is going to be 2 points, so I'm going to pick my first point and my second point, and you'll notice it's created a surface. So I'll click OK, and I'm going to pick that curve. I'm also going to create a sweep. It's still stored my 2 points. You'll notice that it's already created that surface for me. Click OK, and now if I select my database mask and pick everything and go back into my model assembly and click assemble, you'll notice that it heals that as well. So now I have two models. I've got this purple model representing the body and then the green model representing the fins. Okay, so we'll accept that. Now, one thing I want to do is I actually want to remove these little pockets, okay, in the side of the mortar for this simulation. Maybe I'll go back and add them for a more detailed calculation, but in this case I actually want to remove them. So I'm kind of selectively defeaturing my geometry. So how do I go about doing that? Well, before I start talking a little bit about quilts and models, I will talk about that a little bit later. I'm going to mention that I'm going to select my quilt, and really what I want to do is I want to untrim it. So quilt is going to consist of a number of underlying trim surfaces. Now the underlying geometry for this section is actually a cone, okay, that has been trimmed with a cylinder, and all of that information is actually in the background, okay, and we really want to recover that that conical surface, and the way to go about doing that is to untrim this quilt. Okay, again, a lot of that information is in the background. It's not necessarily exposed to you, so we expose quilts and models to you to operate on, so you don't have to worry about the underlying database entities. Okay, the problem is if I select this quilt, so you'll notice actually when I hover over this it kind of selects a lot of stuff, and you'll notice my cursor is this little multi-cursor. That's because I'm actually hovering over top of multiple database entities, and to cycle between them I can just hit the space bar. Okay, so I've basically isolated that entity right there. I can select it, and if I go edit, untrim, I can't actually untrim that hole because that's actually a boundary for that quilt. So the way I can do it is actually to select the quilt on the other side and join those two together by clicking this option up here in the toolbar that says Assemble Quilts. Okay, so I'm going to join those two quilts together, and then I'm going to go untrim, and it'll actually allow me to select those two circles and untrim them. It's going to give me a warning saying that it's going to cause it to be split. That's okay, and we'll click OK. And you'll notice actually if I spacebar through here, it's basically created a closed region on either side, two models. I'm going to delete those, get rid of them, and then I'm going to grab all my database entities one more time and create assemble models, and click assemble, okay, to basically add it back to the model definition. So I've essentially removed those holes from the model. All right. Now I'm going to do the exact same thing for these holes on the back. Okay. So I'll actually walk through this process again so it's clear. Okay. So in this case, there's one. You'll notice this hole up here. That's actually part of the boundary of the quilt, which means that I can't just use this quilt and untrim it. If I untrim this quilt, it's only going to allow me to select the holes that are on the interior, not that hole on the boundary, okay, because it's actually a part of that boundary definition. So I'm going to actually go and select both those quilts, assemble them into one, go Edit, Untrim, and then I'm going to select everything. Now, you'll notice that it actually has selected these end curves. We need to deselect those. So I was just holding down the Control key to kind of deselect those without deselecting anything else. Also, maybe I should note this. If you hold down the Shift key and drag a box, it'll do an inclusive selection. So it'll only select the entities that lie entirely within that box, as opposed to a Control selection. So I'm going to deselect those entities. So I've just got my hole selected. Now the reason those were actually picked is because this is actually a really strange topology for a cylinder. It actually loops back on itself. So you'll see actually when I do the trimming operation or the untrimming operation, I'm going to end up with duplicate models, and I'm just going to need to delete one. This is just something you'll have to kind of pay attention to, and you'll get used to it. But in this case, I'm letting you know that there's actually going to be duplicate models here, and I'm going to remove one of them. So I'm going to do this untrim operation, click OK. I've removed those, and again, if you notice down here, this tells us what we have selected or highlighted. So that's one model. Spacebar again, there's another model. Okay, so I'm just going to delete this one. You'll notice this one doesn't have a seam. It just has two end circles, right? The first model I had, that has a seam on it. Okay, I want to keep that one, but this one right here, without the seam, I'm going to delete that. Okay. Now if I grab everything and go Create, Assemble Models, and click Assemble, now you'll notice I have a nice watertight model for the body of the mortar. And now I can actually begin operating on the fins. Okay. So how do we manage the fins? Well, the first thing I need to do is seal up these holes. Easiest way to do that, grab the database boundaries, and just create a Coons patch. So you can go create Coons patch, or in this case I have my Coons patch button lying in the toolbar. Click that option, created a Coons patch. Do the same thing here. We'll need to zoom in and select those edges. Okay, create a Coons patch there, and I'm going to select my database mask, and using the inclusive selection, shift and drag with the left mouse button, selects just the database entities in that box. Go Create, Assemble Models, click Assemble, and now I have a watertight model representing the fin region. Okay, so I want to join these two models, but in order to do that, I have to trim the fin model with this cylinder. Okay, because it's a watertight model is sealed. It's watertight. Okay, which means that in order for these two things to be watertight, one thing's going to have to give, and it's going to be the fin model. I'm going to puncture a hole in it. Okay, so in order to do that, let me just grab everything and switch to shaded so you can see this pink database surface that's a circle is going to have a hole popped into it. Okay, so the easiest way to do that is just grab the entire model for the fins, go Edit, Trim by Surface. Okay, so that was group selection A. Now it's asking for group selection B, so I'm going to click the body, that's B. It's asking me for an intersection tolerance. I'm going to use an intersection tolerance that was very similar to the value that I was using for my model assembly, so 0.1 will work. Now I'm going to be trimming A with B. Okay, I'm going to be trimming the fin model with the mortar body, but I'm not going to need to trim the mortar body with the fin, so I can uncheck that, and I want to keep the outside. I want to remove that inner ring that's going to be formed, that inner disc that's going to be formed. Okay, click Imprint and OK, and you'll notice now if I select that pink surface, it's had the center chopped out of it. All right, so now I can grab everything and go create, assemble models. Now remember, I keep going into this panel, but you can click this button right here in the toolbar that says assemble models. The reason I keep going in here is so you can see the colors, see the table, see the lamina boundaries are disappearing. Okay, so if I click assemble, you'll notice now I have one model with 0 lamina boundaries. So I have a watertight representation of my mortar. Okay, so we walked through the entire process, start to finish, for cleaning this thing up, creating surfaces to fill gaps, increasing the model assembly tolerance to fill gaps, using the untrim operation to kind of selectively defeature and fill in holes, using the trim by surface to join two models together, okay? Walking through a wide variety of tools that you have at your disposal to clean up dirty CAD, all right? So I'll click OK. Now, here's the fun part. I'm actually going to undo that operation. Okay, that model assembly operation. So I'm going to leave that a separate model. In fact, I'm actually going to select everything in that fin assembly, and I'm going to move that to layer number 20. So in the layer tab, down here where it says layer number, I'm just going to type 20, hit the enter key, and it's basically put it in layer 20, and I can toggle that on and off. Why? Because I'm not quite done with the body. What I'm going to do is grab everything, and you'll notice there's a little rainbow color option in the display properties toolbar. I'm going to click rainbow, and you'll see that each quilt gets its own color. So now's a good time for me to talk a little bit about quilts and models. So a model is a watertight representation of the geometry that consists of a number of quilts. A quilt is a watertight region of trimmed surfaces. It's a collection of underlying trimmed surfaces, okay? Each quilt is going to get its own domain. Remember, a domain is our terminology for a surface mesh, okay? So a model will be guaranteed to be watertight after you've assembled it into a watertight model. That surface mesh will be guaranteed to be watertight, and then the quilts are used to kind of define the surface mesh topology, okay? And what that means is that each of these colors is going to get its own domain, and the boundaries of those colors are going to be connectors or grid curves. And that's how it's going to allow you to essentially extract a hard edge or define a hard edge with a connector. Right? This is really important because this is what quilts and models are used for. This is what they're used for, is to kind of help you define your surface mesh. Right? So it's a very important concept. So now I'm going to actually walk through that. But before I do, there's one more thing I want to do to this model. It's a cylinder. It's symmetric. I actually want to split this thing down the middle. You'll notice that the curves, okay, these lines are actually not all aligned, okay, right? I mean, they're not running down some symmetry plane or anything like that. So I'm going to essentially create my own, okay? And then I'm going to trim this thing with that plane, and I'm going to assemble the quilts on one side and the other. It's always a good practice to have a nice, like symmetric, when you have a symmetric cylindrical model like this, to have two sides rather than having a surface that wraps 360 degrees around for robustness, as well as the ability to go and modify it in the future. Okay. All right. So I'm going to create a plane. So create plane, create a y=0 plane. You'll see the plane that's created right up here. And I'm going to grab the model and go Edit, Trim by Surface. Okay, that was Group A. Group B is the plane. I'm going to be trimming A with B. We're going to keep both the inside and the outside. We'll use the same intersection tolerance we did before and click Imprint. Okay, so now I can just select that plane and hit Delete. So I've got a curve that runs the length of the body right down the symmetry. Okay, so now if I grab everything and hit the rainbow color, you can see there's a few more colors that were introduced because of that intersection. Okay, now what I'm going to do is I'm going to define my quilts. All right, I'm going to essentially assemble quilts into larger collections of quilts to better represent the geometry in a engineering manner, kind of recover the engineering intent of this geometry and define where my surface mesh is going to lie. Okay, So there's a really easy way to do that for this geometry. Rather than just picking quilts one at a time and joining them, we have an automatic quilt assembly tool that works very well for this geometry. So to do this, I'm just going to orient it. I did the -X, so I'm looking down the axis of the mortar, and I'm going to pick my database mask, and I'm just going to do an inclusive selection, so holding down the shift key, and drag a box around, so I'm just selecting the top half. Now, you'll notice there's some small surfaces in here, so you'll want to make sure that you don't get those in there. And so in this case, I haven't got those in there. Now I can go create, assemble quilts, and I'm going to use my angle limit. Okay, I'm going to change that to 10, and that's basically going to allow me to join quilts with a turning angle of less than 10 degrees. So it's going to join quilts that have nice smooth transitions between them, but whenever there's a hard edge, it's going to split it. Okay, and that's exactly what I want, because at those hard edges, I want a quilt boundary so that a connector is created there. All right, so that way I don't have a triangle that crosses a hard edge. All right, so I'm going to click assemble and OK. Now I'm going to do the same thing down here. I'm going to hold down the shift key, do an inclusive selection, go create, assemble quilts, click assemble, and OK. Now if I reorient this thing, I'm actually going to select everything, because you can still see these lines on the interior of the quilts, and that's just the line for the original quilt definition, because I can actually come in here and split. I can actually split this back into its original quilt definition. So the easiest way to kind of get rid of those lines, so you just see the boundaries of the new quilts, the newly joined quilts, is just grab everything, and in the display attributes, you can change it from all lines to just boundaries. Okay. So now you can see exactly what I have for my mortar. I've got two sides. I've got everything split at a hard edge, except for a couple of regions. You'll notice right here at this lip, that's a nice smooth transition. And if you had enough triangles, you could recover it. But I actually want to just split that. So I'm going to grab this quilt and go split. You can also get split from the edit menu, edit split. And I'm just going to pull out this flat surface right here. I'm going to do the same thing here. I'm going to split that. Okay, do the same thing on the other side. Split that. And right here as well. Oops. Split. Making use of that space bar. All right, rainbow color everything. Okay, so now I have kind of the quilts that I want for this case. Okay. Now, why did I turn off and split the tail assembly out there? Just because I didn't want to cut that with the plane. Okay, that's why. I liked the way that was set up, and I didn't want to intersect that with the plane, so I just kind of disconnected it. Okay, so now's the time to reconnect it. So I'm just going to turn on layer 20. I'm going to grab all the database entities, create assemble models, click assemble. Again, we still recover our single watertight solid model for the mortar geometry, and it's all quilted nicely. I'll just grab everything, click the rainbow button to rainbow color everything. Again, the rainbow color is actually really nice because you can see the individual quilts. Okay, but something kind of interesting is happening, stands out. If you come back here, you'll notice that if I hit the space bar, that's a single quilt. So that quilt includes those three surfaces, those three blade surfaces or those fin surfaces, as well as this thin little region you'll notice that kind of connects them all. And the same thing on the other side. So there's actually one more thing I'm going to do, and it demonstrates something else you can do, and that's trimming a surface or a quilt by a curve. Okay, and it's really interesting. So I'm going to zoom in here, and what I want to do is I want to trim that little thin surface away and join it with this blue surface right here, this blue quilt. All right. So to do that, what I want to do is I want to draw a curve from, say, this point on the bottom of this fillet over to the bottom of the fillet on the other side. So I'll have this nice curve that comes across here. Then I can trim it, and then have this surface separate from this little thin region. Okay, so to do that, in the menu bar, I'm going to pick Curve on Database. I'm not going to draw a connector, so the entity type I'm going to need to change to Database Entity. And I'm going to hover over that point right there. And you'll notice every time I move, it highlights a different entity. So I want to make sure when I'm on this point, it's highlighting that surface just like it is right now. And click there. And then I'm going to come over to the other side and click there, and you'll notice it creates a curve right across there. All right. Now, rather than draw that curve for all of those fins, I'm just going to select that. So using the space bar to kind of cycle between all my entities, I'm going to select that curve. I'm going to go Control-C to copy, Control-V to paste, and then I'm going to do a rotate. Okay. We'll do a point and direction, rotate about 0, 0, 0, the x-axis, and because of the number of blades, we're going to rotate this 60 degrees. And you'll notice it creates a copy right there. Okay. So I'm just going to continue to do this. Control paste, rotate 120 degrees, Control paste, rotate 180 degrees, paste, rotate minus 60, paste, rotate minus 120. All right, so I got all those curves. Now, when I drew the first curve, I actually drew it on the geometry. So it is on the geometry, and I can use it to trim it. Okay, you can only use a curve to trim a quilt if it's on the quilt itself. Now, the other ones I just copy-pasted. They have no associativity to the geometry. They're not associated with it at all. I need to project them onto the geometry. It's pretty easy though. We got the list panel. We actually haven't used it yet. We're going to use it right now. If I do a drop down on the database list, I can click Type to organize by type, click the database mask, and here are all my curves right there. This is the first one I drew. It's already on the geometry. Here are the ones that I copied, so I'm going to select those. I'm going to go Edit, Project. Okay. I'm going to do a closest point projection. Okay, you'll notice that 0% are on any geometry. I'm going to toggle off interior only. I want to project all interior points and the boundary points, okay, the end points. And now I'm going to pick my database that I want to project it onto. So I'll click Begin. I want to project it onto that guy. Hold down the Control key. I want to project it onto that guy. End, Project. Now it's 100% constrained to the geometry. And now I can select that quilt. I can select that quilt, and I can go Edit, Trim by Curve. Simple Control A will select all those curves, click Imprint, OK, and now I've trimmed the quilt. Okay, so now you'll notice those quilts are all separate. Okay, which is nice. They are separate, but now the one thing I need to do is I want to join that little, you'll notice there's that little thin ring. And I want to join that with this guy. So I'll go Create, Assemble, Quilts. I'm going to turn off that angle tolerance and click Assemble, and OK. Grab everything, boundaries only, rainbow color, and now I've simplified this a little bit in that region. Okay, so now each one of these things is separate, and now I just have that single quilt wrapping around there. Okay. Now, I didn't have to do some of those steps, right? It depends on how much of the geometry you actually want to recover with the mesh. But in this case, I want to kind of mesh over some of those small features. Okay, so I'm, again, selectively defeaturing some of the geometry. All right. Okay, I'm set. I'm ready to go. I can actually mesh this thing at this point because I know it's a watertight model. I've got my quilts all set up. So I like to spend a little bit more time upstream cleaning and quilting, so that way meshing is pretty much automatic. All right, and when I say pretty much automatic, I mean click the model, click one button, and you've got a surface mesh. Okay, so what I'm going to do is switch to Unstructured up here in the toolbar. I'm actually going to create a triangular surface mesh. It's just as easy to create a structured surface mesh, and in fact I'm going to show you how to create just one domain. I'll give you an idea because the volume meshing procedure is going to be identical for either case. Okay, so I'm going to do Unstructured. In the Defaults tab, I'm going to change this to Average Delta S. This is an average grid spacing. The Defaults tab is going to affect only the entities that you're going to create. Okay, so the entities that you're going to create are going to contain these attributes. All right, that's okay, because if you want to modify them after the fact, you can adjust any of the entities attributes after they've already been created. Okay, because I'm actually going to go and modify a few of the connectors and the domains that were created after this step. Okay, but this gets me like 99% of the way there. So I'm going to set an average grid spacing of 2 millimeters. Why 2? It works for the largest component of my geometry, meaning that it's going to resolve the main body. Okay, it may not resolve the fin region, and in fact that's one of the areas that I'm actually going to go refine, but it will put a surface mesh on the entire body that's watertight, that's not excessively fine. All right, so then I can just go refine it where I need it. Okay, you can do things like max angle, max deviation. You can actually do refinement, curvature-based refinement as well automatically if you'd like. And that's fine. I've used it in the past, and I still continue to use it in some cases, but in this case, the geometry is simple enough that we don't really need to use that. The other thing I'm going to change is I'm going to change the distribution function from the default hyperbolic tangent to MRQS. MRQS is monotonic rational quadratic spline, and I kind of like this a little bit more in some cases than hyperbolic tangent. I'll tell you, for the majority of the cases, hyperbolic tangent distribution is going to work fine. This distribution function controls the distribution of points on a grid curve. All right, it's going to allow you to do clustering and things like that along a grid curve. And what you'll find is if you select a tight spacing at the end of a connector, hyperbolic tangent is going to pull a lot of points towards the end of the connector, whereas MRQS isn't as excessive. Okay, it's going to pull a few points. All right, so that's why I've elected to use it in this case. Okay, one thing I'm going to do right now from the beginning is for unstructured domains and blocks, I'm going to come down here, and for the boundary decay for the block, I'm going to change this to 0.85. And this is basically me preparing myself for the volume mesh. All right, a boundary decay controls kind of the rate of growth from the boundary cells to the far field. So the higher the value, the slower that growth. Okay, so I've changed that from 0.5 to 0.85. Okay. All right, so now I'm ready. I can grab my model, and I can go. What I like to do is I go create on database entities, and I set a connector join angle of 30 degrees. And what this does is it will join connectors on the surface with an angle less than 30 degrees, such that it will reduce the complexity of the surface mesh and reduce the number of connectors that I end up with. Okay, so I'm going to click OK. And it's going to chug away and give me my surface mesh. All right, so there's my surface mesh. I'm going to turn off the database, select my domains, and change them to hidden line. It's a little bit easier to see what's going on. All right, so there's my surface mesh. Works pretty well. Sufficient resolution for the body. Maybe in this region needs to be refined so I can capture that separation that occurs there. Obviously, you can see in the fin region that may need to be refined. While the elements are properly resolving some of the features back here, they're not necessarily going to resolve the flow field once I create my volume. So I'm going to refine some of those regions. And you'll notice actually that some of these regions can easily be, a structured domain can easily be created. So like for example, this guy, if I delete it, I can just grab the connectors here, because at least in this case the opposing connectors have the same number of points, and I can just switch to structured, create a structured domain there, and you'll see I can have like a structured domain. So I can do this over a pretty significant portion of the geometry, because it's not going to change how I do my volume mesh. The technique that I'm going to use to create my volume is TRex. I've talked about it before. It stands for anisotropic tetrahedral extrusion. It works by extruding anisotropic right-angled tets off of the surface in a way that they can be combined afterwards on export into prisms and unstructured hexahedra. Okay, so it'll work off of tris, quads. You can have a mixed surface mesh of tris and quads, and it's going to work great. They'll be face matched, point matched at the interface between the two if you had a quad domain and a tri domain. And it's a great way of reducing cell count, improving cell quality and flow alignment and orthogonality in the boundary layer. Okay. But in this case, again, I'm just going to use all tries on the surface. I mean, you could imagine how easy it would be to do something like this. So for example, I could delete this domain, and all I've got to do for the structured domains is just ensure that the opposing sides have the same number of points. So like this connector and this connector have the same number of points. So I'll just give them like 50 and grab those guys and create a structured domain. So you'll see that obviously an approach like this would really reduce the cell count on the surface. I get hexes in the boundary layer with great flow alignment and that sort of thing. But again, the procedure is going to be the same. Okay, so you could use structured domains over the majority of the body, but maybe where it becomes more complex, like maybe in the fin region, you could go unstructured, for example. And both of these can live in the same mesh and still produce a nice high quality boundary layer inflation. Okay. But again, I'm going all try this time just so I can kind of demonstrate this process a little bit quicker. All right. So I've got my surface mesh. Now I want to refine it, like I said. And I'm going to grab my connector mask. I'm going to grab all of the connectors on the tail. I'm going to hold down Control and Shift to do an additive inclusive selection. Control and Shift, grab the nose, and I'm actually going to refine those connectors. I'm going to go grid, dimension, and change my average grid spacing to 1 millimeter. Okay, and again, this is going to allow me to refine those domains in those regions that need additional refinement. Okay, so if I click OK and zoom in here, you can see that I've refined those domains. Again, the idea being that I refine my boundaries, I refine the domains, and now I can better capture some separation that maybe occurs in this region. But one thing I want to point out is that these nodes, okay, where these connectors come together, if I select the spacing mask here, you can see the spacings aren't exactly the same. Okay, in fact, this spacing is actually twice that of the other spacings, okay, because I just adjusted the connector dimension. It's good practice to have all of the spacings at a node be the same. This is going to improve volume ratios in your actual volume mesh, as well as the extrusion. If it has to come out of a very complex area where there's a lot of curvature or collisions going on, it's really going to improve that inflation out of that area if these spacings are the same. So I'm going to go ahead and adjust that. So let's see, we'd have this spacing, this guy, and then up here at the nose, so those will be 1 millimeter. And it's also a good idea to constrain the opposite end of the connector as well. So I'm going to go ahead and do that with this connector and this connector. I'm going to constrain the other end to be 2 millimeters. Okay, so now my surface mesh is complete. All right, I'm ready to create my volume mesh. So that was pretty quick, right? Click my model, put the mesh on it, modify it as much as we need to, and then we can actually start creating the volume mesh. So what I want to do is I want to create a spherical far field, and there are a number of ways of doing that. One could be to create the circle, like the actual curve, and do a revolve. So in create revolve, you'd create like a semicircular curve, and then you go into revolve to create that spherical surface, and then create your domains on that surface. But there's actually an easier way to do that that's freely available on our GitHub page. You can go there and download a script called Shape Wizard, and it allows you to create some primitives. And I'm going to go through that process. But the first thing I want to do is I want to find the center point of all of these domains. The easiest way to do that is to also run a script, okay, to write a script to do that. Now you can do things like query the begin point, I'll right click, query the, like an end point, and kind of approximate where the center location is. Or you could just run a script and get, for example, the script would get the extents of all the domains that you select and then return the center. And that's exactly what the script does. So I'm going to run that script. I'm going to select all my domains, click done, and it's going to print the center right here to the message window. So I'm going to take that and I'm going to copy it. Okay, and now I'm going to run the Shape Wizard script again, which is available on GitHub, and I'm going to create a sphere. It's going to be a far field. I'm going to create both the underlying geometry and the surface mesh. It's going to be unstructured. Now my average grid spacing is going to depend on my far field size. So for external aerodynamics calculations, for a minimum, I like to have a sphere that has a radius of at least 20 body lengths. Okay. In this case, that's exactly what we're going to use, and that means that I should probably use an average grid spacing of about 2 body lengths at that far field size, okay, which is 1,000, okay, 1,000 millimeters, and that means my radius is going to be 10,000, and my origin, I copied that, so I'm just going to paste that there and click OK. So now I have my far field sphere has a radius of 20 body lengths with an appropriate far field resolution. All right. So now I need to create my block, and it's really easy to do that. I just grab all of my domains, make sure Unstructured is selected, and click this box that says Assemble Blocks up here in the toolbar. And that's going to assemble an empty unstructured block. So it's actually uninitialized. And if you look down here, okay, at the bottom of the screen, when I select that block, you'll notice it says empty. Okay, and the reason for that is when you create an unstructured block, we don't want to populate with elements until you tell us how you want it to populate with elements, because we have to store that data explicitly. Okay, and that can be a lot of data for very large meshes. Okay, so I'm going to populate this using TRex. So with that selected, I'm going to go Grid, TRex, and I'm going to set up my TRex attributes. Okay, again, TRex stands for anisotropic tetrahedral extrusion, and it allows you to do very high quality boundary layer extrusions off of triangles and off of quads, and it creates right angled tetrahedra in the boundary layer that can be combined into either triangular prisms or unstructured hexahedra on export. Okay, so it's a very powerful tool, highly automated. All right, so the first thing I'm going to specify is the number of layers, so 50 layers. I want 1 full layer. So I'm actually going to get more than 1 full layer, but what this is basically doing is turning off multiple normals. So multiple normals means that a convex corner, it will splay off multiple normals to easily wrap around that corner. Right? In this case, I really don't have anything more convex than like 90 degrees at the fins. Okay, but maybe the case of like a 0 thickness wall or something like that, like an infinitely thin plate, you want that turned on so you can wrap nicely around those edges. Okay, so I've turned that off for now. I'm going to change my growth rate to 1.2. In the Advanced tab, I'm going to adjust my collision buffer. I'm going to increase it to 2. And what this is going to do is it's going to allow more room, allow for more room between advancing fronts, approaching fronts, for some higher quality tetrahedra to be developed in those regions. In the skew criteria, I'm going to change my max angle to 160 degrees. And again, these attributes are only going to affect the elements in the boundary layer region. So this is going to prevent any element with an included angle above 160 degrees from being created in the boundary layer region. Okay. There's other stop criteria for TRex, but these are some of the quality constraints that you can put on the algorithm. In the boundary condition tab, I'm going to set up 1 boundary condition. I'll call it mortar, and it's of type wall, and it'll have a grid spacing. This is basically my initial spacing in the boundary layer of 0.002 millimeters. That value comes from my y plus value and the speed of the mortar. Okay, so this is going to be for a y plus of 1. And now what I need to do is just select those domains, again using inclusive selection, and just drop them into that boundary condition. Okay. Now, one thing to note in the Attributes tab under Algorithm, notice that the boundary decay is 0.85 like we set in the defaults panel. Okay, and again, this is going to slow the rate of transition from the kind of the near field cells to the far field. And then I can click Initialize. So I'm actually going to let this go and initialize. It's going to take a few minutes, but I think this is really beneficial so you can see kind of the entire process taking place. I'll zoom in here so you can see these elements coming off of the surface, and you can get a sense for how long it takes to generate, this many elements. And we can also kind of watch the layers. We can watch this table to see how many stop points and non-combinable points we get. What you really want is you want really thick, full layers. Okay, and we're going to get that in this case. I've run this multiple times. We actually end up getting 28 full layers, which is just fantastic. Non-combinable is basically means that at that point it's not going to be combinable anymore, and those will start showing up as yellow points. We're actually not going to get very many of those. And then stopped, those are where points are stopping, and you'll notice that eventually points are going to start stopping locally but kind of continue advancing everywhere else. And the reason being is this region is actually more refined. Okay, the surface spacing is tighter than out here, so we're actually going to see this region stopping sooner because it's reached isotropy. Okay, those elements reach an isotropic state much sooner than the elements on the body. But eventually everything is going to turn red, and that's exactly what we want. It's not turning red because of poor quality, it's turning red because it's reached another stopping criteria, mainly the fact that the elements have reached an isotropic state. Because at the end of the extrusion, this front is going to be passed off to an isotet mesher, and then the remainder of the volume is going to be filled. Okay, so you can actually see the extrusion taking place. Okay, so we've already got 12 full layers. You can see just a couple of minutes we already have 4.5 million elements, 13 full layers. This is being done on a laptop, dual core laptop with just 8 gigs of memory. They're really fast generating these meshes. Okay, so we'll just sit back and watch it. "20 full layers. That's pretty good. And again, keep in mind the algorithm works off of quads as well, again, like I had mentioned before, and instead on export you would get unstructured hex elements. And you could imagine maybe doing, this region is quad and this region is tri, and they would match nicely kind of at the interface between there. All right, so we've got 26 full layers, and it started stopping. Okay, so you'll see eventually more points. Okay, so there's a couple of points stopping as well. We are at 30 layers. There's one non-recombinable or non-combinable point. So again, you'll start seeing these points stopping, and they'll be in this region mainly because those elements are starting to reach an isotropic state, or they're starting to, at this point, kind of collide or about to collide with some approaching fronts, and it needs a little bit more space in there because of the collision buffer that we specified. So you can see how thick this boundary layer region is. It's really nice. And just because points are stopping locally doesn't mean the entire front has to stop. That's the real benefit over a traditional prism inflation, is we can continue advancing everywhere else where there's no problem, where it hasn't reached an isotropic ideal state. Eventually you want the entire front to turn red. Okay, that basically means you've achieved an ideal state, and we can then take that and transition to the isotropic TET far field. So right now, again, the front has been passed off to the isotet mesher, and it's basically filling in the region between that front and kind of the far field. Okay, it's completed, 14.3 million elements, and so I've got my volume mesh. So why don't we take a look at it? The way to do that is select your block, go examine, pick your favorite metric. In this case, I'm going to pick max included angle. A little bit easier for me to visualize how flat a cell is by its included angle. One of the things you can do is, if you check the color bar, you can see the min and the max. You can reset this value to say like 165. If you flip on the histogram, you can see there's 18 cells over 165, and you can zoom in and they'll be highlighted in red, and you can kind of see they're out in the middle of nowhere there, kind of off the body, maybe in some areas where there's collisions and that sort of thing. But one of the things I wanted to show was a cut. So if I turn on a cut and turn off the view of the domains, you can zoom in there and see there's our body. You can see those elements coming off of the surface. Okay, so again, those are right angled tets, and we'll combine those on export into triangular prisms. You can see they come off the body nicely, and you can see the effect of that boundary decay as it moves slowly off of the body and interfaces with the far field. Okay, so now one thing I noticed looking at this, and maybe even after running a calculation, is that I want some additional refinement in the wake. Okay, you know, maybe I need some off-body resolution downstream in the wake. Now, what's a good way to do that? Well, there's a couple of ways, and really what you want to do is you want to embed a block behind the body, whether that be just a refined tet block or maybe even a hex block, so you can get some flow alignment and everything with it. And that's exactly what I'm going to do. Is I'm going to, we'll turn back on the view of the domains here. I'm going to create a hex block in the wake region, and then add that to the block definition. So before I do that, just so it's a little bit easier to see, I'm going to grab these domains and I'm going to change their display type to boundaries only, so we can just see the boundaries. And then I'm going to create a structured domain behind the object, behind the mortar. Now, if I zoom in here, one of the things I want to do is I want to create the block just aft of the fins, but outside the boundary layer, so it allows for a nice smooth transition to the structured block that I'm about to create. And remember, the surface spacing is 1 millimeter. It's had an opportunity to grow, you know, outside the boundary layer. The boundary layers come out about this far, so I want to make sure that the face of my structured block is far enough out, but yet close enough that I have a nice smooth transition between the two. Okay, so I've actually written those points down, and I'm going to reorient this and zoom in here and draw those points. So I'm going to basically create a 2-point connector, a series of 2-point connectors. So the first point is going to be at -535, -50, and 50. So there's my first point. And my second point is going to be -535, 50, and 50. My next point, Z will be -50, and then -50 and -50, and then right back to the beginning. Okay, I'm going to show you a cool little selection trick. If you pick this connector and you do Control-Shift-A, it'll grab all adjacent entities, which is pretty nice. So you don't have to go and pick all the connected entities. Switch that to structured, click create domain, and now I've got a structured domain just downstream of my mortar. And what I'm going to do is I'm going to extrude that just one body length. We'll go one body. You can go one or two or however many body lengths downstream. And so I'm going to go create, extrude, translate. Okay, I'm going to go in the X direction, a distance of 500. We'll flip that direction, and 250 steps, and run that. Okay, so I've created that structured block downstream, and if I just grab those domains and switch to hidden line and zoom in, you can see basically I have a nice uniform structured block. And why is it uniform? Well, it turns out that in order to interface with an unstructured block, a pyramid will have to be generated on the surface of each quad. Okay, and it's better, the more uniform that quad is, the higher quality that pyramid will be that's generated to transition between the two element types. Okay, so that's why I've left it uniform. All right, so once you've done that, really the next step is to add it to the block. Okay, so if you notice, if I just pick one face of the block, I can either pick the mortar face or I can pick the far field face. It'll pick that block. You'll notice it's not a part of that, but it's really easy to add. I can just go to Edit, Add Remove Faces. I'll just pick one of the domains, use my neat little hotkey Control-Shift-A to do all adjacent. Okay, so you don't have to pick each and every one of those domains, and click Save Face. And it'll now add that structured block to the block definition. It basically punches a hole in that unstructured block to fill it with the hex elements that are in that structured region. And click OK. So now if I select, you'll notice that's an interior face in my block. And all I have to do at this point is just go up to the toolbar and click Initialize, and it'll reinitialize that block with the new information. Okay, all the TRex stuff is stored, everything like that. You just click that block, it'll regenerate the TRex region, it'll recreate the isotropic TED region, and then you're done. Okay, so I've actually done that. So I'm going to pull up that mesh so you can see it. So here's a cut through that mesh, and you can see, especially in this region, if I zoom in here, that transition is nice and smooth from just the aft portion of that extrusion off of the fins into the hex region. Okay. You'll also notice if I zoom out a little bit, one more thing I've actually added to this case. Okay. You'll see that there's this nice refined, it looks spherical, and that's because it is. I've actually added a sphere. So if I turn on the view of the domains, I've actually added a sphere on the interior region. So I have a block here, and then I have a block between my larger sphere and the smaller one. And what that does is it gives me more control over the refinement, the cell size, in the immediate vicinity of the mortar and its wake. Okay, so that just provides for more control. And the way I created that was I basically just grabbed the domains for this sphere and just copied them, Control-C, paste, Control-V, and then did a scaling operation. Okay, so you can pick the point, you can pick your scale factor, and you'll notice see that a smaller sphere was created. Okay. All right, so once you're done creating the volume mesh, the next step is to export it to your solver. Okay, so to do that, you would pick your solver. Okay, so I've picked OpenFoam in this case. So you come in here and you pick your solver. You go CAE, set boundary conditions. I've already created a couple, wall and far field, so I'll just go ahead and delete those two and recreate them so you can see. Create two new boundary conditions, call this wall and far field. So type. These types are solver specific, so that's wall and then patch. And these four are the far field, so I'll put them in there. And then if I zoom in, I can use my inclusive selection, pick those guys, and those are my wall boundary conditions. Okay. Now you can also set boundary conditions for like thin features as well. If you wanted to, if you had thin walled regions or anything like that, you could also set those boundary conditions here. Okay. So I've set up my boundary conditions. Now I just, to export, select all my blocks or the blocks that I want to export, go File, Export, CAE, make sure to pick your folder, and well, for OpenFOAM you pick a folder or directory, and then check this box that says combine anisotropic tetrahedra, and that will combine those boundary layer elements into triangular prisms or unstructured hexahedra if you had quads on the surface, and click OK to export it. All right. So that's the entire process, start to finish, for cleaning up the geometry, putting the surface mesh on it, refining it, and then building the volume mesh and even modifying it with things like a wake block or a refined region. Okay. So I hope you learned a lot, and take care.